everyone, and welcome to our webinar today. And today, Hello Data presents Kanguru. This secure your data with hardware encryption, the Kanguru Advantage. Today with me, I'm very happy to invite on this session Mr. Carl Zemke. Carl, good evening to you or good night to you wherever you are calling in from. I believe you are in Boston, somewhere around Boston at this time.
Yes, sir. Good morning.
Yes, good morning. It's an early webinar for us, something out of the norm. Thanks for joining. So, Carl, maybe a brief introduction of yourself.
Of course. Absolutely. Here, let me share my screen. I have a little snippet here for everybody.
So I'll tell you what, Carl, as you introduce yourself and you share your slides, you can take it away. So just for everyone, today we're going to focus on, I'm sure you guys know Kanguru for a very long time. Hello Data has been partnered with Kanguru for 15 years. We're celebrating our 15-year partnership this year. And we decided that since everyone knows our normal encrypted USBs, we would like to highlight this time our SED products or self-encrypting drives. And that's going to be Carl's focus today. So Carl, over to you. And I will jump in if anything. We can definitely see your slides.
Of course. Absolutely. Thank you very much. It's been a good ride so far. Hope to keep it going. It's been great. So thank you for that wonderful introduction, Resham. As he said, my name is Kyle Zemke. I'm Senior Product Manager here at iStorage Kanguru. I've been working in tech for more than 15 years, and I started out as a support rep. I did some IT, software engineering, worked in IT and OT environments, and now I'm here at iStorage Kanguru as a Senior PM. All of my focus in all of my work in tech has been around securing systems and keeping data safe. I really enjoy working with data. I've enjoyed working with Resham and the team here that I have in Massachusetts. And one of my top priorities that myself and the company share is making sure that we keep everyone's data safe through our product line. Aside from the SEDs, we offer USB flash drives, and some of our giant hard drives that we just received are also capable of reaching 24 terabytes of capacity, and we even offer duplicators. But the main focus today is to talk about full disk encryption. We'll take a look at some software-based and hardware-based versions, discuss the differences, and how best to secure your data. One of the things that surprises me is how many people aren't familiar with FDE or full disk encryption, and how many options there are out there for protecting your data while it's at rest. I think a lot of the difficulty comes from people who don't understand how to deploy some of this technology. And hopefully I can ease some of the concerns through my talks and the conversation we have about getting systems built quickly as you would use a regular system with a standard hard drive. So encryption is everything. Cybercrime changes every day, and with more vectors found come new ways to hack systems. With all these offenses that get generated, we need to make sure we have a solid foundation for defense as well. Personally, I believe the future will bring a time when all data is encrypted at rest, and people can worry less about what happens when someone tries to access their data. It's my goal to show everyone here on the call today how easy and accessible securing your data is. And I know that the dev team and the engineering team and everyone here at iStorage Kanguru strives to provide customers with just that type of feature. One of the steps you can take towards reaching data nirvana is full encrypting your hard drive. As I said, if you're not familiar with the term, FDE stands for full disk encryption. But what is full disk encryption? If a padlock secures your gym locker and a combination lock secures your luggage, full disk encryption is like a force field or an invisible shield around your house. It sits at a higher level than the operating system, turning your entire hard drive into a lockbox that can't be opened by anyone else but you. And with only a few steps, you can turn your computer into a fully encrypted system, capable of stopping unwanted attempts to access your drive. Lost drives or stolen drives, critical or confidential data, Cyber criminals can take your computer or your drive, but they can never read or access the data once this full disk encryption is initialized. What makes full disk encryption so important these days? I know sometimes the additional steps can be a little bit scary or daunting, but I have some numbers here that I picked up in some of my studies and research that isn't intended to scare anyone, but it's more of a call to action for the sake of your computer and your sanity, of course. In late 2024, HP reported that 1,800 laptops are stolen daily in the United States. That's not even including globally. That can be either personal systems or corporate workstations. People travel or work remote. Users visit public locations such as coffee shops and cyber cafes. There's a lot of potential for losing a computer. And on top of that, 80% of data breaches involve stolen devices, meaning someone is reading your information and using it to hurt more people. My goal is to talk about how easy it is to set up encrypted disks and compare it to how IT support departments and security departments already functionally build systems for all of their end user computer systems, and how easy it would be to implement full disk encryption instead of just using standard drives. So let's start with an explanation on software-based encryption. Everyone here on the call's probably heard of some form or other of software-based encryption. It's very effective at encrypting your data. You can find applications that are free online and others that offer a paid product and support along with your subscription. With this encryption, one of the most important things to understand as a user is key storage. Managing keys will either make or break your data at rest protection. One of the most popular offerings for software-based encryption is BitLocker. I know that's a keyword that everyone here probably has heard way too many times, but BitLocker has been released and offered by Microsoft since January of 2007. It's included in all versions of Windows and can offer very good protection. One of the things that I have trouble with is BitLocker has a software layer implemented in its encryption process. And one of the things that I've run into is if I implement BitLocker too late in the process, it takes time for the data that I currently have on my hard drive to be encrypted before the drive is ready to receive new data. Sometimes this can take hours depending on the capacity, and I know I can probably speak for most people on the call here, but I like to hoard data, so I have a pretty decent sized internal hard drive. All right, lost my slide for a second. There we go. Some of the examples of other software encryption is Veracrypt and EaseUS. They're offered as third-party alternatives. Veracrypt is a good one for anyone who's using an operating system that is non-Windows, for example, Mac or Linux. And I know some of my colleagues prefer to use EaseUS, Lock My File, for both local files, individual folders, and also full disks. Roshem, do you have any other examples of software encryption that you'd like to add here?
We partner with Jetico that has volume encryption as well, file and folder encryption as well.
Oh, very cool. All right, I'll have to add that to my slide here. So for this demonstration, we'll use BitLocker as an example. Most Windows systems already come pre-configured with BitLocker, meaning you don't need to initialize the security through a lot of steps. It continuously runs while your system is up, turning data into ciphertext before saving it to your drive. The volume master key is stored in your computer's TPM, or Trusted Platform module. So you don't need to worry about choosing a place to store your key. That's a little bit more relaxing because I know the last thing end users want to think about is where to have their key storage. Your data is now protected at rest with BitLocker enabled. One thing to note, there's still a software layer in between your data being encrypted and it's being stored to the local drive. So sometimes larger files can have more harmful saving times. I know you can feel it if you're moving something that's a couple gigs in size or even half a terabyte or so, because it does take a decent amount of time longer than a standard hard drive. But still, you've taken your first steps into securing your computer, so you're good to go. Only there's a slight problem. In order to send the key to your motherboard to unlock your drive, the TPM needs to physically send the key from the module to your motherboard for unlocking your drive. Most motherboards work with what's called an LPC bus, or a low-pin form of communication. This channel is what sends the master volume key from your TPM to the motherboard. The problem lies in that this communication itself is in plain text. If you do a quick Google search or whatever your search engine you're using, you'll stumble across a build or a hardware process where for about 15 or so US dollars, you can get all the parts and components you need and follow the instructions to build a tool that can read from this LPC bus and pull out the master volume key from any laptop or desktop that has a motherboard where the TPM is accessible. There are some security organizations and even some YouTubers who can actually demonstrate this process in under a minute of having access to your computer. I've seen a couple research posts from Hands on Security and Pulse Security. I can always send links to those who are curious about those at the end of this slideshow. Now, those are earlier versions of TPM, but those are still very popular and very active in the population of computers that are in use these days. There are firmware versions of TPM that are more secure, but it's even been proven that those can also be accessed and hacked as well in a similar manner. It's time for a change. BitLocker being around for more than 18 years, it's still having a lot of vulnerabilities that we've seen. Maybe software-based encryption just isn't enough anymore for keeping your data safe. We've been moving on with newer technologies, and we're going to talk now about hardware-based encryption. This form of protection utilizes an onboard cryptographic chip capable of generating a key internal to the drive or controller that governs it. This means the key never leaves the hardware, preventing vectors of attack such as the LPC bus in the BitLocker example. The key itself is stored within the chip, and it's never extradited out for use. All of the information is sent to the drive, meaning that it would require someone to have a lot more skill and effort to try to pull from the hardware, especially if that hardware is protected. When a system is protected by hardware encryption, there's also no performance hit when you're downloading or using larger files for transitioning or transfers. The initialization is similar to a software-based encryption, where you need a software program to kick off the process. But once the drive is running in encrypted mode, you won't have to keep going back to the software layer. This type of encryption is more in-depth for the process, but pays off in better control of the encryption keys and increased performance. As the drives are continuously receiving data, they're also continuously encrypting your data automatically. We can now talk more about a specific type of full disk hardware encryption called an SED. Something that I think is revolutionizing internal storage for critical and remote systems, and I want to talk about it a little bit. SED stands for Self-Encrypting Drive. It means that the drive continuously encrypts data as it's received. Data coming in is encrypted, and data leaving is being decrypted. An encryption key is generated when the drive is first used, and all data added to the hard drive automatically goes through this encryption process. The onboard crypto chip is capable of generating keys for the hardware to use, and the operating system doesn't even notice the drive's extra capabilities. This type of encryption exists outside the operating system, and the same can be said for the user. Once a drive has been unlocked with the proper credentials, it functions like an ordinary drive. The ease of use is a statement itself to show how data protection can be so automatic that you forget you're operating on a hardened system. Our iStorage Kanguru Defender SEDs operate on an architecture designed for this type of data security. This architecture is called Opal. The Opal architecture, created by the Trusted Computer Group, is a means to create a universal secure platform for hardware manufacturers to follow. Opal is a set of required architectural designs that increase security and allow an SED to operate. These specifications have been widely accepted, and many manufacturing companies already build SEDs that are Opal compliant. Every once in a while, I'll be working with someone or be on a customer call and ask what type of drive they use, and sure enough, that drive is Opal TCG 2.0 compliant. iStorage Kanguru is no different, but we created NVMe and SATA drives that support TCG Opal version 2.0. Our SEDs are initialized with a simple software application, and once the credentials are applied, can be operated without any need for software to maintain their secure usage. That means that in some scenarios where an IT department or an end user initializes a drive, after that initial process, the drive doesn't require any maintenance and will remain encrypted for the lifetime of the computer. Let's dig into the hardware and see what these drives are capable of. All of our SEDs are TAA compliant, some with higher end models being FIPS 140-2 certified. Our drives all operate using AES 256-bit encryption and are compatible with most motherboards that support an internal M.2 or SATA slot. So it's not just new and improved systems we're looking to provide encryption for, but also legacy systems as well through our SATA form factor. Let's take a look. So first up is our SED30, which is our fastest model of NVMe. It contains what we call a P-fail circuit, meaning that if power loss is suddenly given and the drive itself still has data to write, it has an onboard capacitor that will try to find a place within the data to stop safely and avoid data corruption as much as possible. It lacks the 140-2 security barrier that our 300 model, which you'll see later, has, but it makes it more affordable for personal and enterprise use outside of the most secure environments. This drive is recommended for anyone who wants to secure their data, especially companies who have a decent number of remote employees. You never know what kind of environments your data will be accessed in. It's always better to have a strong encryption requirement to access. These drives can be mass deployed through a company, and aside from the initial login, will be practically invisible for daily use. As I said before, these drives support TCG Opal 2.0, and this model itself has a capacity of up to 8 terabytes. Next up is our SED 300 model NVMe drive. This drive is FIPS 140-2 Level 2 certified. I'll get into more detail on that after I introduce the rest of the drives. This model can be used in government networks and environments where security is a very high priority, being the complete package of both hardware encryption and hardware physical protection. Like the SED30, the 300 will require an initial configuration with a username and password, but after that drive is set, it will operate forever in its encrypted state unless terminated by a factory reset per your IT department. This drive is offered up to 2 terabytes of capacity. Similarly to the 300 NVMe is our SATA form factor. As you can see, the NVMe definitely is faster for read-write speeds, but this model supports legacy systems. Our pre-boot authenticator offers both UEFI and legacy boot loading options, meaning that if customers have a hardcore industrial environment or anything that is older that doesn't have an M.2 slot, they can still benefit from using one of these drives to keep their data protected with hardware-based encryption. TAA compliance is one of the features that we have with all of our SEDs. We can take a minute to explain more about the TAA compliance and the part it takes in construction. iStorage Kanguru acquires all materials from Trade Agreements Act approved countries, including the US. All the materials used in the production process have gone through strict compliance and approval before transforming them into the SEDs you see today. This makes the SEDs appealing for any country or government entity who puts their trust in the TAA manufacturing process. Resham, are there any form factors or compliances that your company at Halo Data looks specifically for that the SEDs provide?
I think FIPS, as we've seen with external devices, FIPS 140-2 is important, which I think you're going to
Oh
cover.
my goodness, you're psychic. You read my mind here. All right, we can touch base on the 140-2 Level 2 certification. FIPS is closely monitored and restricted by NIST, the National Institute of Standards and Technology. That means that in order to get this certification, a drive has to be conducted through the approved testing. That means that the drive itself passes that it uses FIPS 197 approved encryption algorithms, so that is AES 256 or higher. It survived rigorous testing to try to extract data from the disk. And level 2 also means it contains a tamper-evident security barrier, which also prevents contacts from anyone trying to skim data off the printed circuit board or trying to use leads to pull data from any of the crypto chip or pieces of the circuit. But how are these drives initialized? Introducing iStorage Kanguru's Opal Commander software. We use Opal Commander, a program installable on both Windows and Linux, to search for Opal 2 supported drives and initialize them for use. As you can see here, I'm sharing a screenshot of a drive that I use, and it also provides its health information. The drive here is currently encrypting data but hasn't been activated yet, as you can see where it says Opal inactive. That means that the pre-boot authentication hasn't been installed. Once I do take this drive through initiation, the drive will be prepared to run consistently and continuously without any external need for software or control changes to the drive. The user interface is simple and straightforward. In companies that wish to deploy our SEDs, this software would be used at the IT support level. Once the drive is processed and finalized, there's no need for the software to be used by the end user, and the drive can normally function for regular use. This is just a brief list of some of the functions that Opal Commander provides. As I said previously, the program would be used to configure the drive, then the drive can be installed in a workstation. Most of the tools we provide are also available through our pre-boot authenticator, which I'll dive into next. So if you aren't familiar, what is a pre-boot authenticator? Basically, it provides an area outside of the operating system for users to provide their credentials to unlock the drive. Our SEDs come with a dedicated read-only space for this pre-boot authentication program. This user interface provides a list of available SEDs on board for unlock, and you just need to put in your username and password to access your operating system. Here's a screenshot of the PBA. Like I said before, this read-only space doesn't need to be updated, so as long as you're satisfied with all the available onboard features, you don't have to make any changes to the drive, meaning a single installation of the PBA could last the entire lifespan of the disk if necessary. If you have a very remote location or you have a secure system that can't have any downtime, then you have no problem running this PBA for the lifetime of the drive. I'm sure there are a lot of questions related to the SEDs. They seem really cool, they seem really effective, but how complicated is it if I want to deploy this to my entire company or a sector of my company or multiple countries of offices? Surely it can't be that easy, right? Let me see if I can make it easy and simple for you. One of the benefits of self-encrypting drives is that they function like normal hard drives do before you initialize it with credentials. So it's fairly easy for you to clone or duplicate drives. And I know this because I've done it in the past, and it's a very common practice for most IT departments who are in charge of deploying workstations. A single golden image or golden copy of the Windows operating system or the Mac Linux operating systems with an application set can be applied to a single drive and then cloned infinitely until you have enough workstations as required. This concept helps to scale procedures into fully operating potential. And with the golden image in your hard drive, you can use a single NVMe or SATA drive to clone the image to multiple SEDs. This can be done by any safe duplication process, whether it's software connecting to a single computer and flashing all of the drives, or using something more physical. For example, iStorage Kanguru offers a few different duplicators that are NVMe, and I have some SATA duplicators as well. We offer 4 target and 11 target duplicators that can be used to assist you in massive deployments of workstations with hardware encrypted drives. Let's say you need a fully supplied new branch of your company, and you've got a whole bunch of SEDs that need to be done. Once you have the default image in place from a single hard drive, if my calculations are right, you're looking at 60 fully duplicated drives in about an hour. That's not bad for deploying hardware-based encryption, especially when it's only 1 or 2 additional steps from using a standard hard drive that any IT company would have already used. Once all the drives are cloned and ready for processing, how do you configure them for encryption? We offer a second tool. We call it the mass provisioning tool. On screen right now is a screenshot of its easy-to-use UI. It has an increased capacity to affect multiple drives at once. Now, these processes run in parallel, so you can connect as many drives as possible on a Linux-based duplicator system, or if you're running it on Windows, you're limited to the amount of alphabetical letters, but we can get into that later. This allows you to set a bunch of default credentials to a large group of SEDs in a single run. It's very similar to deploying a bunch of systems or workstations to a bunch of end users. You would set a default username and password, send it to the end user. On first use, they would be guided through the PBA and change their password, and then they would have a fully encrypted, easily accessible workstation for use. Your IT department will share any details and instructions with the end user, and they can customize it as needed. Like I said before, all these protocols are standard for an end user, and they wouldn't notice anything different aside from just providing one set of credentials to see Windows. We want to provide our customers with all the programs they need to achieve full data protection at rest to all systems, everywhere, all the time. One of the things that I'm really hopeful for is what the future will look like. I think every computer system is deserving of encryption, and we're getting closer and closer to that type of world. One of the most important things is the protection of keys. And in my previous discussion, when I was talking about software-based encryption versus hardware-based encryption, the key storage is very different. With BitLocker, you're using an external module to save your encryption key, even if it's on the same board or in the same system. Whereas our SEDs that were hardware-based encryption, the key never leaves the chip. The crypto automatically generates a key when it's initialized, and it continues to use that key without having to extradite it to a foreign source or even alternate circuits in the system. Makes it virtually invisible for the end user, and they don't have to make any configurations or manipulations to the drive. My hope here is to inspire as many people to protect their data and use hardware-based encryption to help avoid the threat of cybersecurity attacks that grow every day. And it's really good to be prepared for these kinds of things. A couple of points that I think will benefit a lot of the people here today and probably answer a lot of questions already. So Q&A might be a little short, Rasham. Working on some additional FIDO support here at iStorage Kangaroo for multi-factor authentication using something like a key token, Fails or YubiKey, or your standard FIDO supported token for additional protection when the drive is required access for credentials. We're also working on streamlining the process so IT departments can have an even easier time deploying these drives and building workstations at a higher speed with the same amount of efficiency. But what's most important that we're working on is the ability for companies and organizations to monitor these internal drives. And that's by making them remotely manageable and accessible through our KRMC, or Kanguru Remote Management Console, our hosted server platform. With this type of technology, we will be able to discover any drive, whether it's being accessed by the correct user or not, and disable any drive that's connected anywhere around the world. So companies can rest assured that as their employees become more remote, or as their end users travel or need to go from location to location, that all of their information on their computers are protected and remain safe, even if they're stolen or taken. This just adds more benefit and more oversight into the already very difficult to break hardware-based encryption. Rishem, that concludes my slideshow, and I'll be open to lots of questions, and I can also show some physical versions of the product as well.
Thanks, Carl. Very informative session. I think a lot of people will be very excited to test it out. But if you are, most of the Hello Data offices will already have a sample. If not, please reach out to them. They should be able to have a demo drive for you. I've got a few questions that came via WhatsApp. I think Mr. John had asked a question about the Kanguru external drives. I think we will take that offline. But the questions I've received, and everyone, please feel free to ask questions in the Q&A chat. So some questions I've received over WhatsApp is, can these drives be used in a server environment or a NAS, and how would you configure that? Because some of that will be storage and some of that will be operating system.
That's a great question. So through some of our testing, we were able to set up RAID configured servers where if the PBA is loaded and configured on all of the drives, you should be able to launch into the PBA and it will see as many drives that are connected to the PC. And by doing that, you can unlock all of them with either the same credentials or individual credentials. So when the system performs its soft reboot, it will load into your standard RAID array.
Right. That's great. We have another question. Will the SED300 need the Opal Commander to be installed on every PC that is using the drive?
Another good question.
Yeah.
No, the Opal Commander software is meant to configure the drive initially for use. A lot of the features and functionality that Opal Commander provides can be found inside the PBA. If you need to perform a factory reset or take control as an administrator, you don't need to have Opal Commander installed. It rests inside the PBA, which is the read-only space.
Can it be used as an external drive?
Yes, absolutely. If you have Opal Commander, you can currently use it as an external drive. We offer a unlock and lock function, as well as something we're working on in the future, which is an installable version of our very popular command console program that will also be able to use these SEDs as externals.
So as of today, we would need to have the Opal Commander if we want in every PC to use it as an external drive.
That's correct.
All right. Okay. Another question that came through is, I have BitLocker, and one of the key factors that we use it is the ability to manage keys when someone leaves the organization and forgets to give us the password back, or we need to reset the BitLocker password. How, when you talk about enterprise, how do we manage the keys, or how do we manage the drives? I know you said earlier on that KMC will be coming out soon, but as of today, how would an organization manage access to the drives if they get it returned and stuff like that?
So as of today, if the drives are returned, like you said, someone could log in as an administrator and modify the username and password to be provided to a new user. If there's a situation where the drive is lost or stolen, if the password isn't provided, the drive can't be accessed. Like I said, with the connection to KRMC for remote management, we have a feature already on some of our other Defender line models that we have a connection to Active Directory. So for example, when this feature is available, if someone is disabled or removed from Active Directory, any drives that have their credentials connected to them will automatically receive a disable action.
Right. Now, in terms of the administration of the drives, um, what is the how to say the mechanism? Can there be an admin user that also is used to log in a drive, or the admin only can do it through the command prompt?
So the drives support
Or-
two users. One is at administrative level that can perform all the roles and responsibilities to access and configure the drive. And the other is a standard user. In a lot of the deployments at the enterprise level, you would have an IT department or someone use unique administrative credentials for each drive and then would provide separate credentials to the user. So if anyone ever decided to leave the company and the computer was returned, we wouldn't have to bother them for their credentials. We could use the IT team's credentials to access.
Okay, another question. What does the PBA image provided default by Kanguru provide, and how do customers customize their own PBA and any image extensions allowed? Three questions in one.
Of course, absolutely. So we can provide additional extensions on an as-needed basis. I know you've been asking for a Halo Data specific PBA, and I'm working on that one to have a nice Halo
Yeah.
Data logo in the background.
Yeah.
So if anyone is interested, we can also do customized PBAs in that basis. As for tools, the PBA actually includes our Linux version of the installed Opal Commander. So you'll have things like access to terminal if you need to troubleshoot or debug anything for internet connection. You'll have Opal Commander for performing password resets or resets to factory, as well as anything at the lower level functioning in a Linux-style pre-boot environment, along with the PBA's credentials to unlock the drive.
Right. Another question is, SED does the SED engage with the TPM chip at all?
No, it does not. The drives themselves are fully encapsulated in all of the Opal 2.0 architecture. The access from the drive is only at the behest of the PBA before the operating system starts. Once the drive is unlocked, it will function as a standard NVMe or SATA drive, and it works in the background. So there's no concern for keys being stored outside of the chip or extradited by any application available.
Is there a difference between embedded, like can we use it in ARM architecture or only Intel architecture at this point?
That's a good question. I would have to do some testing. A lot of ARM style architectures are very different. Right now, the current PBA works in a UEFI style bootloader and a
Right.
legacy style bootloader.
Right.
If that's supported by the ARM architecture, it should be plausible, yes.
Okay. A follow-on question. Are we able to restrict certain functionalities of the Opal Commander, because administrators might not want their users to be able to reset to factory default, but still want their users to use the SED as an external drive?
Yes, there will be ways to do that. Once the initial setup for remote management is provided, administrators can create custom settings that will prevent any of their end users from performing features or setting changes that they don't authorize.
As of today, with the Opal Commander, can we control the Opal Commander? I think the person asking this question, please reach out to us offline. We may try to have a special version of Opal Commander for you with those functionalities disabled.
Absolutely.
Yeah,
I'd be happy to talk about that. Yep.
sure. Um, yeah, I think that's about it, Carl. A good bunch of questions. And I think anyone who's really interested to see a demo or to get more information, contact your Hello Data representative. And Carl, thank you for staying up late. We also had on the call, without forgetting, Don Wright, who's head of marketing at iStorage Kanguru, also up late at this night. So thank you guys for joining the session today. And for those of you who want to see the recording, we will be able to send it off once the webinar is over and the marketing team sends it out. Thank you all very much for your time, and we shall see you at our next webinar. Thank you, Carl.
Awesome. I'm looking forward to the next one.
Cheers. Thanks. Bye, everyone. Thank you for your time.